guys, today we'll teach you about how the Newton's law of motion work.
For example, gravitational force is part of the situation when the gravity pulls downwards the person. Gravitational force with which the Earth, Moon, or other massive body attracts an object towards itself. For example, gravitational force is part of the situation when gravity pulls downward on the person.
Normal force is a support force exerted upon an object that is in contact with another stable object. So, when an apple, I'm gonna draw an apple. When an apple is on the desk, the normal force is exerted on the apple, so it comes from here.
Right. Friction force is the force exerted by a surface when an object moves across it, or tries to move across it. Here's an example. The notebook is sliding on a desk. So there's a desk, and here's my notebook, right here. Friction is exerted on the table and is one of the forces that is making the notebook slide to the right. So it's sliding to the right, and our friction force.
So, for the tension force, it's transmitted through a spring, rope, or wire when it's pulled tight by forces acting at each end. So, for example, a spider is suspended from the ceiling. And what makes it stay there is the tension that is transmitted through the web. So here, it's the tension comes from here.
Spring force is exerted by a spring or elastic material when it pushes or pulls an object attached to it. A person pulls an elastic. So there's a person, and he's pulling an elastic. And this is the person later. And the elastic is over here now because he pulled it further back. And it's like pushing that way.
So, applied force. Applied force is the force that is applied to an object by another object or by a person. So, an applied force can be found when a person, for example, puts the backpack on the table. So, here's the table. And then somebody puts the backpack on the table. So like, since this person got the backpack, this is an applied force because you're applying a force on the backpack in this example, for example.
Air resistance, or drag force, a special type of frictional force that acts upon objects as they travel through the air. The force of air resistance always opposes the motion of the object. It's most noticeable for objects that travel at high speeds or for objects with large surface areas. So when a player throws the ball on the basket, so here's a basket, let's say that's the rim, and here's our player. Kind of short, but he's throwing the ball this way towards the basket, and the air, which let's say this is air, it's pushing back at or FD. Sorry.
Okay. So now that you know what are the forces, we'll get deep on how it works. Have you ever heard about mass and weight? So let me tell you the differences and connections between them. So mass. An object is a measure of the object's energy property, or the amount of matter it has. So mass is measured in kilograms, right? So mass doesn't change in different places. So example, an astronaut is on Earth. Yeah. That's Earth. And goes after to the moon. So if his mass on Earth is 85 kilograms, for example, his mass will remain the same in other planets. So that means that on the moon, he would still have a mass of 85 kilograms. Has 85 kilograms on Earth, he would have on the moon the same mass because it doesn't change.
Weight. An object that is a measure of the force exerted on the object by gravity or the force needed to support it. Weight is measured in newtons. So weight equals N. Weight would change with location because it depends on the level of gravity. Weight an object that is a measure of the force exerted on the object by gravity, or the force needed to support it. Weight is measured in newtons, as we said before. Weight would change with location because the different levels of gravity. Now, if the astronaut goes to Earth, so let's say this is our astronaut, and this is Earth. So, okay, this is somewhat Earth. Earth. Okay, and he goes to Earth as 85 kilograms. So 5 kilograms. Okay, so he goes to Earth, which is 10 gravitational force. So it'd be 85 times. Okay, so now if the astronaut goes to Earth at 85 kilograms, then the gravitational acceleration would be 10. Now, if the astronaut goes to Earth, you would find his weight by multiplying 85 kilograms times 10, because 10 is the gravitational acceleration, so it would be meters per second squared, which gives you 850 newtons.
So when you want to find the weight, you need to use the equation Fg equals mg. So why? So weight, it's Fg, and mass, it's m, and the gravitational force by acceleration is g. So acceleration is g. So when you want to find weight, you do Fg equals m times g. Now, when you want to find the mass, you have to do m equals Fg divided by g. And whenever you want to find the gravity, you need to do g equals Fg divided by m.
Newton's first law states that an object at rest tends to stay at rest, and an object in motion tends to stay in motion with the same speed and in the same direction unless acted upon by an unbalanced force. So here's our example. If a person, right here, is falling at a constant terminal velocity, so he's going down this way. Let me draw a FBD graph. So this is our gravitational force, and he's falling this way, so yeah, this way. Then once he reaches maximum speed, then the drag force, which is the air resistance that's going this way, will balance out and make it equal.
There are two parts of this statement. predicts the behavior of stationary objects, and it predicts the behavior of moving objects.
Okay, so now the second law works a little bit different. If there's a net force exerted on an object, the object will have an acceleration and the object's velocity will change for a specific force. The acceleration of the object is directly proportional to the net force and inversely proportional to the mass of the object. The direction of the force is the same as the acceleration. So basically the equation for that would be A equals net force equals mass times acceleration. And our units for that, so let's say units equals Newton. And then 1 N equals 1 kilogram, 1 meter per second squared.
Net force. What's net force? So before explaining Newton's first laws, you need to know how the net force works. So net force happens when there is an unbalanced force, which exists when all vertical forces and all horizontal don't cancel each other. So net force is actually a vector sum, which is the result of all the forces that act upon an object. So you have this symbol that means sum of. And the net force equation would be EFN minus FG equals 0. The last and the third law is when one object exerts a force on another object, and the second object exerts on the first an equal force in the opposite direction. The third law applies on two different objects, the action force, when one object exerts on the other, and the equal but opposite reaction force, and the second object exerts on the first. So, reminder, action and reaction forces never balance out because they act on different objects. So, the first example we have is when a bird hits a plane. I'm very bad at this. Okay, let's say no. Let's say that's the plane, and then a bird hits the plane. So the plane hits the bird to the right, and the bird hits the plane to the left. The second example is when the foot hits the ball to the right, and the ball hits the foot to the left. Thank you for watching. Here is Victoria and Tyler. Bye!